from the daytime side of Venus to the nighttime side, smoothing out the temperature differences. This is because the circulation patterns in the thick atmosphere are highly effective at. It's a thick atmosphere, so the circulation patterns are very effective at carrying the hot air from the daytime side of Venus to the nighttime side of Venus. Oh, because you're sick. Oh. Oh no. The high time, or sorry, the high temperatures at the surface of Venus is a result of the greenhouse effect. As discussed before, we talked about the greenhouse effect gases or the greenhouse gases the other day on Earth. The sulfuric acid clouds of Venus reflect about 75% of the light that strikes them. The sulfuric acid clouds of Venus reflect about 75% of the light that strikes them. Below the clouds, however, the atmosphere is nearly transparent at visible wavelengths. If you walked on the surface of Venus in a highly heat-resistant spacesuit, because yeah, it's hot there, it's closer to the sun, right? The light level would be about the same as during an overcast day on Earth. So like the light level, if you walked on the surface of Venus, is about the same as on a cloudy day. So like Ohio. So Venus is kind of like Ohio. However, the energy absorbed by the planet's surface is re-radiated as infrared light, to which the atmosphere is opaque, thanks to its high carbon dioxide content. The surface air pressure on Venus is 92 atmosphere. Look at that. That's a lot. Where 1 atmosphere is around 10 to the 5 newtons per meter squared is the average sea level air pressure on Earth. So the thing that's 1 atmosphere for us is more like 92 atmospheres on Venus. The surface air pressure on Venus is 92 atmospheres, where 1 atmosphere is around 10 to the 5 newtons per meter squared, which is the average sea level air pressure on the Earth. The composition of the atmosphere on Venus is 96.5% carbon dioxide and 3.5% molecular nitrogen. That's good. I mean, nitrogen is good. One intriguing question is why the atmospheres of Venus and Earth are so different from each other. Venus and the Earth are nearly twins. This is what I was saying earlier, another day, that they're very much similar in size. Like Venus radius is 0.95 our radius, so it's a little bit smaller than Earth. And the mass is 0.815 our mass. So a little bit smaller than our mass, but very similar. Venus and Earth are almost like twins. Good, yeah, get some rest tomorrow. The key difference between the 2 planets in this context is that the Earth has liquid water covering most of its surface. Obviously, right? Oceans. Carbon dioxide dissolves in water, where it forms, among other compounds, negatively charged bicarbonate ions. So carbon dioxide plus water will give you H plus HCO3 minus. The bicarbonate ions combine readily with any calcium ions dissolved in the water. So Ca2 plus, so ionized calcium plus 2HCO3 minus gives you carbon dioxide plus water, H2O, plus calcium carbonate. Calcium carbonate is poorly soluble in water, so it precipitates out to the ocean floor. Limestone, which occurs in abundance near the Earth's surface, is a sedimentary rock that consists largely of calcium carbonate. Limestone, which occurs in abundance near the Earth's surface, is a sedimentary rock that consists largely of calcium carbonate. Since Venus, hi baby, hi Shona. Since